Alright folks, so this week we're going to be talking about material jetting additive manufacturing. Now material jetting is kind of like a conglomeration of a few different types of additive that we've already talked about, and it can be found in chapter 7 in your textbook. So what material jetting does is it actually uses an inkjet style printer head, so very similar to binder jetting like we talked about last week. But rather than printing onto a bed of powder, material jetting is actually jetting a photopolymer, just like we talked about with that polymerization, but it's actually jetting out a photopolymer straight onto a build platform. Okay, so what you have is you've got that inkjet print head, it's jetting out a photopolymer, and then directly behind it, it hits it with a UV light. So that UV light hardens that photopolymer, and since that photopolymer hardens so quickly, then the bed can move down and it can print another layer on top. So it's very, very efficient as far as how quickly it can work, because it is not only solidifying that material, it's able to build on top of it really quickly. The other cool thing about this is when we talked about polymerization, that there are so many different types of polymers that you can have in a liquid form. You can take all of those materials and put them through a material jetting machine. So what does that mean on a practical basis? That means that you can actually do multi-material parts all in one go. So let's say, let's talk about, for example, a drill. With a drill, you've got a plastic handle, and then typically you've got a rubber grip on that handle. With material jetting, you can actually print all that in one part, in one time. You don't have to glue it together or print it separately. It'll actually print it all as one piece. So this is really great for prototyping. It is used a little bit in final production, but it's typically used for prototyping and then like tool making for manufacturing. So I'm about to show a video. This is from Stratasys. And they are going to go through and tell you a little bit about how the technology works, give you some case studies, things like that, and then based on that, we're going to go through this week's assignments. All right, so let's check it out.
Multimaterial manufacturing processes are rare, both with conventional methods and 3D printing technologies. Without multi-material capabilities, prototyping and manufacturing become expensive, time-consuming, multi-step operations. Traditionally, products are divided into individual pieces, one for each material and color, and made separately. With multi-material 3D printing, parts and assemblies are produced in just one step, making the prototyping process efficient, fast, and inexpensive. PolyJet Connex is a unique multi-material 3D printing technology with 3 operating modes: mixed parts, digital materials, and mixed tray. In one step, mixed parts makes products with a variety of materials. This eliminates the need to make multiple parts and then have them assembled. Digital materials are a combination of 2 or 3 PolyJet resins blended while printing. This yields a wide selection of composite materials with varying physical and visual properties. The mixed tray mode prints several parts at one time, each made with a different material. This improves response time and operational efficiency. PolyJet multi-material 3D printing has just one difference from single material printing. To print multiple materials, each area must be designated as a discrete shell in the CAD software. To generate these shells, segment the 3D CAD model into different bodies, one for each material, before exporting in the STL or VRML file format. The files are then imported into PolyJet's processing software, where the materials are assigned. The next step is to 3D print the part. When the job is complete, simply wash away the support material. Companies use multi-material 3D printing to simulate rubber products like gaskets, tires, and footwear soles with digital materials that range from as soft as a rubber band to as hard as a shopping cart wheel. Combine rubber-like materials with rigid plastics to produce overmolded products like toothbrushes, razors, and power tools with soft-touch gripping surfaces. Combine opaque and transparent materials to make prototype eyewear and display panels, anatomical models, and medical devices. Use color to give models and prototypes the appearance of final products without painting. When applied to text, decorative accents, or logos, color adds the finishing touch. Use PolyJet multimaterial throughout the product lifecycle. Convey design intent with realistic concept models. Analyze form, fit, and function with prototypes that simulate production material properties. And once the design is finalized, use the 3D printed product as an end-use item, as many users do with jigs and fixtures, artistic pieces, special effects items, and gaming figures. PolyJet multimaterial printing reduces time and cost when compared to traditional prototyping methods. By simplifying the process, companies report savings of 50 to 90%. Those savings are the result of increased productivity. The one-step process eliminates tooling and most of the direct labor expense. It also minimizes the need for secondary operations like painting and assembly. Productivity is also increased through greater 3D printer utilization with far less downtime for material changeovers and single print jobs that produce many parts in a variety of materials. Prototypes have full product realism that comes from the array of colors, opacities, and material properties. This allows design teams to produce more design iterations of lifelike products in less time, which means that errors are detected far earlier in the process. Multimaterial technologies are rare, while multimaterial products are common. That's why you should take a look at PolyJet Connex 3D printing. Discover how efficient and cost-effective it can be for all of your multimaterial 3D printing needs.
Alright, so I hope that you picked up a lot of good information from that video. From here, I want you to go ahead and go into your assignments, and I want you to do a little thinking this week. I'm not just giving you everything in the lesson, so I want you to go through your textbook, just look into it, base your answers off of the questions that are being asked, of course, and use your textbook. Also, the internet's your friend. Use that as a resource. And I want you to come up with some information for your assignment and also the discussion. You don't have a quiz this week, so don't worry about that. But go ahead and get that assignment and that discussion done, and don't forget to comment on 2 other people's posts. So, have a great week. If you have any questions, feel free to reach out to me. I am available. Thanks.